All right. So I'll kind of get you guys going on this a little bit. So for the bonding review, again, test is on Tuesday. Okay. All right. So the outermost electrons that are involved in bonding are known as, valent, or valent. I call valence. Sorry, you guys are right though. Valence electrons. Okay, so valence electrons. Ionic bonds occur between what two types of elements? Nonmetals and metals. And I would just make sure you put a positive symbol because every once in a while, if you have a polyatomic ion that's positive, that's also true, right? But usually what we rely on is metals. All right. Covalent bonds occur between nonmetals and nonmetals. All right, when lithium atoms react with bromine atoms, so lithium is Li, bromine is Br. So you know that lithium is a metal or nonmetal? Remember, we're looking at that stair step. It is a metal, good. So this is our cation. And then bromine is over on the right-hand side, so that's our anion, right? So it has a +1 charge, has a -1 charge. All right, so lithium ions lose 1 electron to form an ionic bond. Okay? All right, how many total atoms are in this compound right here? So when we're looking at number of atoms, we're paying attention to our subscripts right here. So we're going to have 4 plus 10, which will give us 14. In potassium bromide, the compound would have alternating positive or negative potassium ions. So potassium is K. Is that positive ions or negative? Those are positive. Good. So these are your cations. All of your metals are cations. And negative bromine ions. Okay? So those are your anions. How many valence electrons do the elements have in each group? Or each group have, sorry. So remember, we're paying attention to the A's on our periodic table, right? So we're looking at what group they're in, what column they're in, and then you have the labels up here with the A's on them, and that'll kind of help you out with how many valence electrons there are. So group 1 has 1, group 2 has 2, group 13 has 3, 14 has 4. Exactly. Okay, so those are our main group elements. We don't really talk about the valence electrons on the transition-ish metals, right? The ones in the center. All right, draw the Lewis dot structure, the electron dot notation, for sodium, aluminum, nitrogen, and bromine. So sodium is in group 1A. So how many dots will it have? Because, yeah, it's all about valence electrons, right? So we're going to draw 1 dot, group 1. Aluminum is in group 13. So aluminum gets 3. So we're going to go 1, 2, 3. If you drew it on the top, that's fine too. Okay. And then nitrogen gets how many? 5. 1, 2, 3, 4, 5. Bromine is in group 17, so it'll get 7. 1, 2, 3, 4, 5, 6, and 7. Okay? All right. This is that one that we did kind of in our journal. So remember, we're going to start with our formula and name, right? So start with the formulas and names. That's the easiest way to do these. So we have lithium and we have sulfur. So looking at the oxidation numbers to make our formula, your oxidation number. So lithium, down in the bottom right of your reference page, you see that you have, for lithium, is a +1. So we're going to go ahead and write Li with a +1. Sulfur is in 16. Well, so it's a 6 valence electron, but it's a -2 charge. Exactly. Yep. So then you crisscross those. We end up with, I guess I could have done this over in this box, my bad, but you would have ended up with Li little 2, and then 1s, right? So you have Li little 2, 1s. This is lithium sulfide. Okay, so when we go to draw this, remember during the electron transfer is the arrow part. So you're going to draw lithium, who has who is in group 1. Sulfur is in group 16. So looking at the different valence electrons, we know lithium is going to get drawn twice. Each of them has 1 dot. There we go. And then sulfur, there's only 1 sulfur. He's in group 16, so he gets 6 dots. So 1, 2, 3, 4, 5, 6. We're going to go ahead and show the transfer with arrows. And then we're going to show what they look like after. So we're going to have Li with a +1 charge, another Li with a +1 charge, and sulfur completely filled up with that -2. Okay, so I'll save that last one for you, but just to kind of at least help you with what the formula would be, strontium is Sr, so strontium is in group 2, which means he has a +2 charge. Iodine has that -1, so when you crisscross, you end up with 1 strontium and 2 iodines. Strontium iodide. Nope, just iodide. Di is a prefix. Those are only for the covalent ones. Okay. All right, number 9 down here at the bottom, it says the electrons between atoms and molecules like Cl2 and H2O are being shared, transferred, or transferred, lost, gained, whatever. So Cl2. So Cl2. What are we dealing with Cl and Cl? Metal and nonmetal, or nonmetal, nonmetal? They're both nonmetals, yeah. So these are both nonmetals. So when we have 2 nonmetals, this will definitely be a covalent. What happens with the electrons? Are they shared or transferred now? Cool, I'm glad we have silence. So what I'm going to have you guys add to your little notes in your journal, nonmetal, nonmetal, sharing electrons. That's the big thing about these covalent bonds. Sharing electrons, okay? So up here, electron transfer, lost, gained. Sharing electrons is specific to covalent, okay? So back to our review. We're going to have shared, circled. Same thing with our hydrogen and our 2 hydrogens and an oxygen, right? These are all nonmetals again. So it's the same thing. It's still going to be shared. Okay? Any questions on the front so far? All good? All right, flip it over. On the back. All right, so I'm going to help you with these top ones because I know it was on the last test, but you still are going to get asked 1 or 2 of them. So compounds that have the weaker bonds. I'm going to have you actually cross that out. I don't like that question. Because we're not going to talk about that part. Because it really has to do with intermolecular forces. We're not going to discuss that right now. So compounds that will conduct electricity in water, that's going to be ionic. Okay? Compounds that have low boiling points, that is covalent. Compounds that do not dissolve in water is going to be our covalent, so insoluble. And then compounds that have high melting points is going to be ionic. Yep. Okay. I think you guys are perfectly capable of using your notes to kind of get these drawn out for yourselves, but you want to make sure that you're going to be able to use those notes pretty effectively, so I would just make sure you look those over. The electronegativity difference. All right, so for this, you have on the back of your resource page all of your electronegativity values. So since you, unless you're going to jump onto Schoology to look at this at home, I would do these right now real quick with me. So we have F2. So I want between F and F, right? F and F. So we're going to find electronegativity of fluorine. Fluorine is 4.0. And I'm going to subtract 4.0. What does that equal? 0. All right, so anytime that we have this diatomic idea, we're ending with 0. So the scale is actually going to be 0 to 0.3. This is from your lab, was nonpolar. 0.4 to 1.7 is going to be that polar range. And then above that would be your ionic range. So you can put 1.8 plus. It's a silly looking 8. All right, that's okay. All right, so here we have a 0, so we're in the nonpolar. CaBr2. So we have Ca and Br. So calcium is going to be 1.3. Bromine is going to be 2.8. So 1.3, 2.8. So this will give us a negative answer, which is fine. It will give us 1.5. Did I do that well? Yeah, 1.5. So it'll give us a negative 1.5. Don't worry about the negative. We're taking absolute value because we just want the magnitude of the difference, or the difference of their magnitudes, right? So 1.5. Looking up here, what did that just put us in? In the polar, right? But you guys know it is going to be ionic because it has that metal. Finally, carbon and oxygen, you're going to have 2.5 and 3.5. She'll give you 1. So now you're back in the polar range. And that's it. You do want to practice your Lewis structures. Do not come in without any of those done because you'll want to check your answers with me on Tuesday morning. Okay? But you guys got a 3-day weekend. Enjoy it.